Hello students, welcome to EPG Pathshala. Today we shall be studying about the application of geospatial technology in air pollution management. As you all know, air pollution has been gaining greater attention in the last few years due to rising and alarming levels of air pollution rise in various countries across the world. So today in this module we shall be studying about these air pollutants, their health impacts, their sources, how these air pollutants are monitored as well as modeling, and the role of geospatial technology for the management of air pollution for its effective mitigation. As you all know, geospatial technology comprises of remote sensing, GIS and GPS. The remote sensing technology helps in acquiring information without actually being in physical contact with the object. GIS helps in analysis of the data thus collected through remote sensing, and GPS technology helps us in locating these places on the surface of the earth. So in this module we shall be studying about the role of all these technologies that together comprise geospatial technology for the pollution levels monitoring and management of air pollution for its effective mitigation. As you all know, air pollution is one of the major concerns in all the countries that exist throughout the world, be it a developed or a developing country. It has become an alerted global issue as a large amount of pollutants are being discharged into the atmosphere every day. Environmental pollution is our concern nowadays because all our daily activities are directly or indirectly related to the environment. Air pollution in the Asian countries are increasing at an unprecedented rate. Although higher level of air pollution is mostly concentrated in the urban areas, but rural areas are also approaching these alarming levels at a very fast pace. The World Health Organization (WHO) has reported that in developing countries, air pollution in urban areas has resulted in over 2 million deaths per annum, along with various cases of respiratory illness. The major contributors of air pollution are the transportation, that includes the automobile sector, which is the greatest contributor, the commercial activities, the industrial processes, as well as domestic indoor pollution. So, apart from the gases such as sulfur dioxide, nitrous oxides, and carbon dioxide, carbon monoxide, etc., a major portion of air pollution is caused by particulate matter. The particulate matter, it includes the solid and liquid particles that are suspended in air. These particulate matter can be divided into three categories based on their aerodynamic diameter. The first category is PM10, which includes the particles that have aerodynamic diameter less than 10 microns. Second is PM2.5, in which the particles have aerodynamic diameter less than 2.5 microns. And the last one is PM0.1, which has aerodynamic diameter less than zero point 0.1 micrometer. Now coming to the health impacts of air pollution, the most common health problems that are caused because of air pollution are related to the following body systems, which could be respiratory. As we know, the lungs are the main receptors of pollutant levels. Second is cardiovascular, if these pollutants are transported throughout the body with the aid of blood. Third is ophthalmologic related to eye. Fourth is dermatologic related to skin. Neuropsychiatric, which is related to irritation and other problems of mind. Hematologic, blood related. Immunologic, which affects our immune system and the reproductive system. The most susceptible group of people to air pollution includes children and the elderly people, as well as those who are suffering from respiratory or cardiovascular diseases. Since for these people, even a small amount of pollutant or the air toxicant can be very dangerous. Even healthy people can experience these health impacts from the polluted air, causing symptoms such as irritation in the respiratory tract or breathing difficulties during the exercise or outdoor activities. The current health status, the type of pollutants, concentration, and the length of exposure to these pollutants actually defines one's actual risk to the pollutants or their adverse effects. Now, coming to the sources of air pollution, these sources by which the air pollutants enter into the atmosphere and thus to our body can be broadly categorized into two categories: natural and anthropogenic. The natural sources include those which are beyond our control, such as forest fire, volcanic eruption, wind erosion, pollen dispersal, evaporation of organic compounds. The anthropogenic sources, they include transportation, industrialization, biomass burning, energy production, agriculture. So basically, the anthropogenic sources are those that are caused by human activities which release various air pollutants into the atmosphere that ultimately find their way to our body. The next topic is monitoring of air pollutants, which is quite important considering the rising level of pollution. In India and several other countries, monitoring is done manually using various air samplers such as high volume samplers, fine particulate matter samples, indoor and handheld samplers, gaseous samplers, laser based instruments. Monitoring is an expensive process and it requires expertise of people handling the instrument and quite a large manpower. So, the geospatial technology, if it is used wisely, can be used to continuously monitor these air pollutants and identify the possible sources of pollutants for their effective management. As we have studied previously, geospatial technology is a term that is used to describe various modern tools such as remote sensing, GIS, and GPS that help us in contributing to geographical mapping and analysis of Earth's features. With the invention of computers, storage and transfer of images, together with the development of associated softwares, maps, and data sets on socio-economic systems as well as environmental phenomena, has become quite easy. So, accordingly, there are several types of geospatial techniques, that is, geographical information system, remote sensing, GPS, and internet mapping technology. Let's have a look briefly at these technologies. Remote sensing, it is used for collecting information about the earth or its surface features or any phenomena occurring on the surface of the earth without having any physical contact with the feature or the phenomena. So this technique, it utilizes sensors mounted on a platform that measures the energy reflected from the earth. These sensors can be mounted either on a plane, or it can be airborne, or it can be satellite borne. So there are basically two types of sensors: passive sensors and active sensors. The passive sensors utilize solar energy for studying the various objects and phenomena on the surface of the earth. The active sensors, they use their own source of energy for illuminating the target and thus studying the features. These include sources such as lidar or radar or sonar. This figure shows us the active as well as the passive sensors. As you can see, passive sensors, they utilize the solar energy for studying features on the surface of the earth, while active sensors such as lidar uses laser beams which it targets to the object, and after it's reflected back can be used for studying the features on the surface of the earth. Remote sensing finds varied applications for studying Earth's surface features such as land use, land cover mapping, urban planning, monitoring of forests and wildlife, transportation, watershed, as well as wetland management. These are a few of the applications, and there are many others which we will be seeing in the coming modules. The next technology is Geographic Information System, which we popularly call as GIS. It is a tool used for working with the geographic information, that is, the data that is pertaining to space. In simple words, GIS is computer software that links the geographic information with the descriptive information. It has developed rapidly since 1970s in terms of both technical as well as processing capabilities, and today is widely used all over the world for a wide range of purposes. It is a computer-based system that provides four sets of capabilities to handle georeference data. It includes data capture and preparation, data management, data manipulation and analysis, and data presentation. GIS also has a broad range of applications such as intelligence, environmental pollution, crime mapping, education, health and human services, natural resources, transportation, setting up of utilities such as pipelines or cable networks. Now coming to the role of remote sensing and GIS in air pollution management. See, the ultimate goal of any air quality management plan is to ensure minimal impact of pollutants on human health. Therefore, the exposure to pollutants and health assessment becomes the major component of a management plan. And to get information about these two parameters, continuous monitoring is very important. This monitoring is usually done by regulatory monitoring authorities such as Environmental Protection Agency (EPA), Central Pollution Control Board (CPCB), and State Pollution Control Boards, that is SPCBs. Thus, these air pollutants and the human health have relied on the ground measurements which are done by CPCBs or SPCBs so far, and in the last few years they have incorporated geospatial technology as well. So, although these ground based measurements are considered to be the most accurate, but this approach has certain weakness. The ground monitors cover the area sparsely and it's difficult in unevenly distributed areas. Further, this ground based monitoring is mainly focused in the urban and maybe some suburban areas. To overcome these issues and to get continuous data, the use of remote sensing technology has increased in the recent past. It covers a larger area that includes the remote areas as well, where human access is generally difficult. Although the use of satellite remote sensing data has been used to track particulate matter and air pollution events since 1970s, the quantitative studies of atmospheric particles began after the launch of NASA's Terra satellite in December 1999. Nowadays, many countries are using satellite data to monitor as well as manage their air quality. Now, management and monitoring of air pollutant using GIS. This can generally be done by integrating database operations with the map making ability of GIS and includes operations such as query and statistical analysis with the visualization and geographic analysis, thus making it a powerful tool to explain events, predicting possible outcomes, and planning abatement strategies. The air automatic systems contribute to identify changes in the environmental quality continuously over time and space, thus helping to determine in a quick manner and detect early problems of environmental quality data serving for environmental management and protection. The required parameters that are measured in the field include wind direction, wind speed, temperature, relative humidity, and pressure. Besides, the other parameters that are included are sulfur dioxide, nitrogen dioxide, carbon monoxide, ozone, and particulate matter. Thus, these parameters they can be incorporated with different types of dispersion models in GIS such as AirMod, Caline 4, OSPM, CalPerf, CalGrid, EDAMS, ADMS, etc. These models provide information about different pollutant and dispersion patterns of pollutants. From the obtained data, the manager can give out timely warning and propose the appropriate measures to manage, control, and protect the environment as well as identify the responsibilities of the production facilities or industrial zones of cities. So, as you all know, remote sensing plays a crucial role in management and monitoring application. Its application is really important in the context of estimation of aerosol optical thickness or aerosol optical depth, which is known as AOD or AOT. Moderate resolution imaging spectroradiometer that is born on Aqua or Terra platform, multi-angle imaging spectroradiometer popularly called as MISR, and visible infrared imaging radiometer suite that is VIIRS. The aerosol optical thickness or the aerosol optical depth is defined as the integration of aerosol extinction coefficient along the entire vertical atmospheric column and is considered as one of the essential climate variable that influences climate, visibility, and the quality of the air. This satellite derived AOT represents the amount of the particulate matter present vertically in the atmosphere of the Earth and can be considered as an overall indicator of pollution in any urban area. The aerosol concentration can be measured directly by the ground based sun photometer or estimated by sensors on the satellite. As you can see in this figure, we have given various methods that are used for measuring aerosol optical depth. The first one is satellite remote sensing, which we just discussed. The airborne measurements using maybe balloons or aeroplanes or helicopters. Besides this, the aerosol chemical, physical, and optical properties are also studied by ground based measurements. LIDAR, sun photometer are used for measuring the aerosol optical depth as well as the radiance properties. The data obtained from the satellite provides information about the aerosols at larger scale with moderate quality and lower frequency. The satellite data also provides data for other pollutants apart from particulate matter. For example, there are satellites that provide information near the surface on ozone's chemical precursors and volatile organic compounds. There are several instruments that measure infrared wavelength of light to infer the concentration of carbon monoxide. Instruments that observe thermal infrared wavelength can measure carbon monoxide in free troposphere, although the vertical resolution of these instruments is not that good. So, the management process requires information about the pollutant, and after getting requisite information about the pollutant, it becomes easy to manage. This eventually provides the evidences which are used in establishing the source transport receptor relations of aerosols over a synoptic scale. Moreover, the satellite data of atmospheric composition are often used to identify the pollution emission, the transboundary movement of the pollutants, the forecasting of the air quality, and also relating the air quality with human health. This geospatial technology helps us in providing information on how much exposure of a population that is affected, and it also determines the environmental impacts of these air pollutants from the present to future developments. Therefore, it gives a chance to the decision makers to establish strategies that can minimize the pollution levels. This can also provide data about the population health risk status, like information regarding cancer, allergy, and respiratory problems, and the data can be used effectively to tackle the root cause of the problems related to air pollution. So, dear students, at the end of this module, I hope you would be able to appreciate the role of geospatial technology in monitoring as well as managing the air pollution. In this module, we have studied what are the various air pollutants that includes both gases as well as particulate matter, the classification of these particulate matter, the health impacts of these air pollutants, the various sources that contribute to air pollution, as well as the managing and monitoring of these air pollutants. The monitored data can be integrated into GIS technology and remote sensing technology with various models that we have discussed in this module, and these models are very effective in managing as well as mitigating the air pollution levels. I hope you all have been benefited from this module. Thank you.